introduction for Chapter 3. That's pretty cool. So these are the last two rules. Yes. These are the last two functions that you really are going to be expected to know. And then, yeah, that's like all the derivative rules. All right? So, just put them on my desk. That's fine. All right, so it says sketch the graph of e to the x, and then sketch a possible graph of f prime of x. Confirm using your calculator. All right, what's the only thing you need to remember about e to the x? No. It goes up. What's the one point you have to remember? What is it? All of YouTube is watching now. You know that, right? It's not bad. It's not bad. What's this point right here, Mike? 0, 1. All right, so that is e to the x, right? So we want to figure out what its derivative is. All right, so do you guys have your calculators? Yeah. All right, so put in e to the x and the y1. So where's e to the x? Second. All right, now if you want to graph the derivative again, hit math button. Math 8, hit number 8. Now we're taking the derivative with respect to x. Now you can either type in y1 here, or you can just type in e to the x again. It's math 8. Yeah. So math. It's the same thing. If you have the older one, you just want to type in math 8, and then you want to type in e to the x, comma x, comma x. So you have x e to the x yeah. Yep. Yeah, if you have it the old way, you'll type in e to the x in the y1, and then y2 you'll do e to the x, comma x, comma x. Make sure you close your parentheses. Just regular, so hit zoom 6. All right, so what do you notice? They graph the blue thing, e to the x first, and then the red line is the derivative. It's the same, right? So e to the x, very nicely, is the most difficult rule you'll ever know. The derivative of e to the x is just e to the x. So the derivative of e to the x is just itself. Yep. Right, yeah. So the only thing you have to remember with e to the x is like if your exponent is something different besides just x, then you just have to do chain rule. Right? But yeah, the derivative of e to the x is just e to the x. I don't really need it anymore. So. Now, if you have something different as your exponent, remember it's going to be that exact same thing, and then you have to remember to take the derivative of the exponent. That's what that u prime means. Okay. So it'll be just like a function. So if I were to say, take the derivative of e to the 2x, right? 2x in this case is the u function. So the derivative of e just becomes e to the 2x, and then the derivative of the exponent is what? 2. So your answer would be 2e to the 2x. Mm-hmm. So again, if you have something that's like besides just x to the first, if it's anything different than that, again, when you take the derivative of this, it's the exact same thing again, times this is now the derivative of your exponent. Right? And then you just simplify. Sometimes, but rarely ever. Most of the time it's more difficult than that. Yeah. Yeah, exactly. Yep. All right, so you got e to the x plus x squared. So what would dy over dx be? Right? Times what? One plus 2x. Right? So dy over dx is just 1 plus 2x e to the x plus x squared. You can distribute if you would like, but you don't have to. Doesn't really help anything. Yep, yeah. So derivative of again, this stays the same, and then the only thing you're really taking the derivative of is the exponent. Yep. Pretty easy, right? Because Anya was asking if that was the final answer. So that was my answer. Yes. It is right here. Easier for her to find. I'm trying to be helpful. Okay, how would I rewrite that? Probably chain rule here. So I have cosecant squared of 5x cubed. So I'm going to have cosecant of 5x cubed squared. Right? I can put that exponent on the outside. So now the derivative. So sorry. Now you just rewrite it so you can put the exponent on the outside. It's easier to find the derivative then. So work your way outside in. So the derivative of e becomes just the same thing, right? So you have e cosecant squared of 5x cubed. Yeah, but eventually you're going to want to put it back like that, right? All right, now times the derivative of cosecant, which is, right. So you have negative cosecant of 5x cubed. Yes. What are you doing? What are you doing? Larry, get out of here. What are you doing? Mr. DiRienzo's trying to get on my computer. Who had a question? Yes, what did you? Oh, yeah, we forgot about that. Good catch, Samantha. All right, it's good. So you bring down the 2, then you have cosecant of 5x cubed. Not yet, not yet. So what we did is we took the derivative of the entire exponent, right? So we brought down the 2, which gives us that. Now we need to work on the inside. So now the derivative of cosecant, right? Lot of chains in this one. So you have negative cosecant of 5x cubed cotangent of 5x cubed. And then the last part is just the derivative of what you're taking the cosecant of, which is just what? Right. 15x squared. All right, now you just clean it up. So I see that I have a 2, a negative 1, and a 15. So I'm going to put that out front. So I have negative 30 x squared e to the cosecant squared of 5x cubed. And then you have now cosecant of 5x cubed times cosecant of 5x cubed times cotangent of 5x cubed. What does that turn into? Good. 5x cubed no. And that would be your final answer. Yep. All right, so again, you got the 2, you got the negative 1, you got the 15. That's negative 30. You got the x squared. Bring down the e, and then you have cosecant times cosecant, which is cosecant squared, and then the cotangent. Good day, guys. Guys have questions about 3.8? Come see me tomorrow.